Okay, so moving forward with our problem here, so let's get our calculator to solve for the area of the sector here. So that's going to be equal to 27 all over 360 multiplied to 81 pi. Okay, so that's going to give us, okay, 19.085. Okay, 19.085. Then we have to subtract that from 81 divided by 2, then sine of 27. So that's going to give us 18.3866. 18.3866. And when we subtract that, 19.085 minus the answer, so it's going to give us 0.698. Okay, so therefore that's the very small area that Matt needs to find in order to build his teleportation device, his portable teleportation device. So that's going to be equal to 0.698. Okay, or okay, that's right, 0.698 squared inches. Okay, so that's the area of the segment SW. There you go. Okay, so moving forward with our next question. Jania is planning to create a circular swimming pool together with her friends and their family for the elderly. Okay, so and they've created a home for the elderly and they had a pool, okay, given here on the right. So the said circular swimming pool has a radius of 21 meters. Okay, so its radius is 21 meters and a central angle of 99 degrees. So, okay, Jania and her friends plan to build a hot tub balloon or a relaxation area here. Okay, they plan to build a hot tub, okay, or a relaxation area here at the bottom for the elderly who would like to take a nice warm bath on segment RT. So how do we get the area of segment RT? Okay, so to do so, we first need to find the value of the central angle right here. So that's going to be equal to 99 degrees. Okay, so our theta is equal to 99 degrees and our radius is now equal to 21 meters. So using the area for finding the segment, okay, segment of a circle, so that's segment RT. So this is the area of the hot tub, the part of the hot swimming pool, the hot tub area. So this is going to be equal to equal to the measure of arc RT all over 360 multiplied to pi r squared, okay, and then minus 1/2 of r squared sine of theta. Okay, so this is going to be equal to, since the central angle is 99 degrees, therefore the measurement of arc RT must also be equal to 99 degrees all over 360 multiplied to pi, and the value of r is equal to 21. Okay, 21 squared minus 1/2 of r squared. Okay, the value of r is 21. Okay, 21 squared sine of, okay, 99. Okay, because that's also the central angle. So using our calculator here, we have 99 all over 360 multiplied to 21 squared times pi. Okay, so that's going to give us, okay, 380.99. Okay, 380.996491 minus, okay, 21 squared divided by 2, and then multiplying that to sine of 99 degrees. So that's going to give us 217, okay, 217.785271. 52791. Okay, so we have to subtract 380.9966491 from 217.785271. So the answer here, the area of segment RT, okay, is going to be equal to 163.21 squared meters. There you go. So that's the area of segment RT. So the area of segment RT is equal to 163.21 squared meters. Okay, so for word problem number 7, we have here Clarice Fay is trying to construct a research laboratory for extraterrestrial plants on one of the stations found on Saturn. So the research laboratory is built by experts from different nations on Earth. So it has a radius of 41 yards. Okay, so this is the radius, 41 yards. And one of its central angles is measuring angle SAM, okay, SAM is equal to 135 degrees. So we need to find the area of this pink shaded area. So how do we get that? Okay, so to do that, okay, first, okay, so we're going to do a bit of a reverse computation for the area of a sector. Okay, so to get the area, okay, the area of the pink shaded region, first we have to solve for the area of the circle, which is pi r squared. This is the formula for finding the area of a circle. Then that's the time that we have to subtract the area of the sector that we have here. Okay, so again, for finding the area of a sector, the formula is going to be the measurement of arc SM all over 360 multiplied by the area of the circle. Okay, so to do so, okay, to solve for this problem, we can plug in the value of the radius, which is 41 squared. Okay, 41 squared minus the measurement of arc SM. Since the central angle theta is equal to 135 degrees, then the measurement of arc SM is also going to be equal to 135 degrees. All over 360 multiplied by the area of the circle, which is pi multiplied by 41 squared. Okay, so this is going to give us 41 squared pi. Okay, 41 pi squared. So this is going to give us 404. Okay, 404.6537804 minus, okay, so we have here the area of, okay, the circle, okay, multiplied to 135 all over 360. So that's going to give us 151.745167. And if we subtract 404.6537804 from our answer here on 151, this is going to give us an area of 252.91 squared yards. Okay, so this is the area of the pink shaded region. Okay, so to get this, again, we have to solve first for the area of the circle, the area of the entire circle, and then we have to subtract the sector here, or the slice here. And after subtracting that from the total area of the circle, we get the area of the pink shaded region. Okay, so there you go. It's 252.91 squared yards. Okay, last problem. Elizabeth is trying to create a new outdoor game for her friends and family. So to do so, she needs to create a square court with a side measurement of 8 feet. Next, she inscribed a circle G inside of the square, with the square's 4 sides tangent to the circle G. Okay, and creating a circle A on the other side. Okay, as shown on the figure on the right. So we need to find the area of this lavender shaded part, okay, from the outdoor game that Elizabeth is trying to create. Okay, so to do so, let's focus here on the figure that we have here. So this is the constructed figure that we have. Since we know that the side measurement, so since we know that the side measurement of the square is equal to 8 feet, therefore, if this is the radius and the radius of the circle is found at the center, okay, at the center of the square, so therefore this side must measure, or this radius must measure 4 square meters. Okay, and therefore if this is 4 square meters and it's being shared by both circles G and A, therefore we have here also this radius is also equal to 4 feet. Okay, so that if that's equal to 4 feet and this is also equal to 4 feet, okay, we can create a perpendicular bisector here. Okay, so we've created a perpendicular bisector DP that extends to the lower side of DP also, which we can connect to the bottom part here. So that's the X. Okay, so this is the perpendicular bisector, and we have here a 90-degree angle. Therefore, we will have created two right triangles. Okay, and since this is a perpendicular bisector, it makes sense, or it's logical, that it bisects this segment right here, GA. So GA measures 4, and 4 divided by 2, so we can get that the measurement of PA is equal to 2, or 2 feet. Okay, so we will have created a right triangle. So this one is theta, then this one, okay, this radius measures 4 feet, and this one measures 2 feet. And we need to find the measurement of this one. Okay, we need to find the measurement of this side in order to solve for the area of this given segment. Okay, so to do so, to find the area of this side, okay, we can use the trigonometric ratios that we have learned on the third quarter. So if you remember, guys, the Sokatowa Choshakao. Okay, so from the first three, okay, we can use the sign. Okay, but since we're trying to, since we're only given the adjacent side and the hypotenuse, okay, we cannot use the sign. Okay, so therefore we're going to use the cosine trigonometric ratio for this problem. So that's going to give us cosine theta is equal to the adjacent side all over the hypotenuse. And we know that the theta here, okay, so the theta is missing, and this is the one that we want to solve, okay, this theta right here. So since theta is missing and we know the value of A is equal to 4, and the value of the value of A, the adjacent side, is going to be 2, and the hypotenuse is 4. So therefore, this is going to be equal to cosine theta is equal to 1/2. And to solve for the value of theta, then we just solve for the inverse, okay, the inverse trigonometric ratio of cosine, okay, 1/2. Okay, and to look and using our calculator, we can solve for that value. So that's going to be the inverse, okay, inverse of cosine all over 1/2 multiplied to 1/2. So that's going to give us that the value of theta, okay, theta is going to be equal to 60 degrees. Okay, so if this part, guys, okay, let's try to concentrate on this angle. Okay, let's focus on this angle. If this is 60 degrees, then it must mean that this angle right here adjacent to theta is going to be also equal to 60 degrees. Therefore, this angle right here that's going to intercept arc dx or dgx, that's going to intercept arc dgx is equal to 120 degrees, because 60 plus 60 is equal to 120 degrees. So therefore, the measurement of arc dx, okay, the measurement of arc dx is going to be equal also to 120 degrees. And from here, guys, we can now solve for the area of the segment here. We just use the formula for finding the area of a segment. Okay, so we solve first for the sector, and then we subtract the segment from that one. Okay, so this is going to be equal to, okay, so the area of segment dx is going to be equal to the measurement of arc dx all over 360 multiplied by the area of the circle, pi r squared, minus 1/2, okay, 1/2 of the radius multiplied by sine theta. Okay, so this is the area for finding the segment. So the measurement of arc dx is equal to 120 all over 360, that's the one that we solved a while ago, multiplied to pi, and r squared is going to be simply 4 squared minus 1/2, and then again 4 squared sine of 120. Okay, so solving for the value of this one, it gives us, okay, so 120 all over 316 multiplied by 16 pi, so this is going to give us 16.75516,082, and then we minus that to this area of the triangle. Therefore, this is going to give us 4 square root of 3, and therefore 16.75516,082 minus 4 square root of 3 minus the answer. This is going to give us 9.83. So that's the area of the segment dx. Okay, so area of segment dx is going to be equal to 9.83 squared feet. And since we need to multiply that to 2, that's going to give us, okay, so 9.83 times 2, since there are two parts there, so that's going to give us 19.65